In the last video, we have seen how to create a forward pass for the required function and find the gradients of the function using the Autograd feature in Pytorch. In this video, let's consider the example function and implement the gradient descent to find the right parameters of the function which we have seen in the last video. This time, let's have x as inputs as 100 random integers between -100 and 100. So, I'll define x as x equal to torch.randint -100, 100 dtype equal to torch.float32, device equal to CUDA0. This will generate the random integers between the range -100 and 100. And let the equation for the true values of y be 1.8x plus 32. I'll initialize the values of w and b equal to 1 just like this. W equal to torch.once 1, requires underscore grad equal to true. Device is equal to CUDA0. B is equal to torch.once and inside the parenthesis it is 1, requires underscore grad is equal to true, device is equal to CUDA0. We will consider the same simple model, so y hat is equal to w into x plus b. So I'll set up the number of epochs as 100,000 with a learning rate as very small value like this, that is 0.000001. Yes, I have selected these hyperparameters based on my trial runs. Then I'll create the loops. For that, for I in range epochs, loss equal to torch.sum y hat minus y whole squared. That means I am considering the loss function as squared error loss. What it is? Squared error loss. Once we have computed the loss, we will then call the backward on loss function. So it is loss.backward. Observe this very carefully. If I simply update the required value of w as w minus learning rate times grad w, then the system will record this as another relationship between two variables instead of the simple mathematical calculation. This is because we have set the variable w as required underscore grad as true. So, to switch off the computation of gradients in the equation, we will include the following statement. What it is? It is with torch.no underscore grad parenthesis and a colon. And any statements we write inside the block, the system will not compute the gradients but only performs the mathematical computation. So, inside the code block, I'll write the update rules of w and b. That is, w equal to w minus learning rate into w.grad. And b is equal to b minus learning rate into b.grad. Okay, once this is done, we have to set the values of gradients to be equal to 0. Hence, we will call as w.grad.0 underscore parenthesis and b.grad.0 underscore parenthesis. So, this will set the value of grad w and grad b as 0. After this, I'll compute the y hat with the updated values of w and b. And this cycle repeats until the total number of epochs. And finally, we will print the values of w and b. And now, if I execute this, yes, we now have the results. We have the values of w and b as 1.7999 and 31.995. It's approximately same as our true values of parameters 1.8 and 32. With this, we come to the end of this video on implementing the gradient descent from the scratch using Autograd functionality in Pytorch. So guys, I hope you had fun in this section and I hope to see you all in the next section for more learning.